Now let us understand what is the concept of continuum. Continuum in thermodynamics. You can see that here in this container there are lot of molecules, a fluid molecules, maybe it is gas or liquid, it's a fluid molecules. These are in continuous motion, and you can see the right side container here. These molecules are slightly separated. Here the molecules are almost close to each other, and you can see that the first container follows the continuum. You can use the continuum approach here, and the right you cannot use, that is a rarefied. Here the gas molecules are widely apart. So let us see what is continuum. So, continuum approach means that you can take the matter as a homogeneous, continuous homogeneous matter with no holes. You can see that there is a slight gap between these molecules. Okay, but we need not, whenever you calculate the properties, you can neglect these gaps and assume this gas as a continuous homogeneous matter with no holes. That is called continuum approach, because you are neglecting all the gaps between. Okay, so that is so throughout this course we will use the continuum approach for each of the system, because almost all the systems that we encounter in engineering applications, here you can use the continuum approach easily, because these are not rarefied gases. So when can you use this continuum approach? So you can see these gas molecules inside this container, still actually it is moving, so there is a gap between them. So this, what is lambda? Actually it is not the gap between these molecules, but actually it is the distance traveled by the molecules between two successive collisions. This is called lambda, and this L is the, see, this is a dimension of the container. It actually it is the width, and here also you have length. So usually the dimensions comes like this 100 into 50. You can see that these are almost similar. None of the container will come like this, zero point 0.1 etc. These are almost of similar dimensions. Okay, 10 into 5. So again, the order of the dimensions will be same. So let us take the dimensions be L. L means either the length or width. Okay, so you can take the continuum approach, use the continuum approach only if the mean free path lambda is much less than the characteristic length. It's the only way you can use. Okay, whenever you use the, if you use a continuum approach for a system or a control volume, then you need to make sure that the mean free path of the gas molecules is much less than the characteristic length. Characteristic length means the dimension of the container. Okay, but see here this is a gas. Here the water can be taken as a continuum, because there are, we can neglect all the gaps between the liquid molecules. Actually there will be some gap, but we can neglect all that. Okay, so what is the dimension? This Knudsen number is the dimensionless number that used to make the distinction between, differentiate between continuum and rarefied gas. So how, what is Knudsen number? Let us see. Knudsen number simply means is the ratio of lambda by L. Lambda doesn't mean the gap between the molecules, it simply means the distance traveled by the molecules between two successive collisions. Okay, between these collide each other. So that is lambda divided by L, characteristic length. If it is 0.01, that means this lambda is very much less than this length. That then you can make the approximation. Okay, then you can make the uh, approximation that the gas is a continuous medium. So that means whenever the uh, gap between the molecules is very low, then it will become a continuous matter. Okay, so this is the concept of continuum, And how you can make a differentiation between continuum and a rarefied gas, that is by the Knudsen number. So here lambda is the mean free path, okay, and L is the characteristic length. Okay, now once we have understood what is continuum, now let us understand some of the important properties of the matter. So first property is the density. We have already seen what is volume, and you know what is mass. So mass by volume is density. Okay. And what is specific volume? Specific volume, I told you, that is the total volume divided by mass, that is equal to 1 by rho. So this is the specific volume. Okay, so these are the some of the important properties of the matter.